look at this machine. Not for a second, not in passing. Really look at it. The way it moves tells you everything. Slow, deliberate, uninterested in speed. This is not a bulldozer built to rush. It was built to dominate time itself. The Komatsu D575A exists because at one point in history, engineers decided to stop asking what was reasonable and instead asked what was possible. For decades, the logic of heavy machinery was simple. If the job is too big, build a bigger machine. If it takes too long, add more power. If the ground resists, push harder. That mindset worked until it didn't. By the late 1980s, open pit mining was changing. Faster than machines could keep up. Pits were deeper. Overburden was thicker. Haul routes were longer. And downtime was no longer an inconvenience. It was a financial disaster. Komatsu studied this problem carefully. They looked at fleets of machines working together. They looked at cycle times, they looked at fuel consumption, and then they made a decision that would define an entire era. Instead of many machines doing small work, they would build one machine to do the work of many. Not incrementally larger, not slightly stronger, radically bigger. The result was not an evolution, it was a rupture. This bulldozer was so large that it could not travel on public roads. So heavy the bridges were irrelevant. So wide that standard transport did not exist. Before it ever moved a single blade of earth, the D575A had already proven something important. It could not exist in the normal world. To reach a mine, it had to be broken down into massive sections, shipped separately, transported across oceans, reassembled on site with precision measured in millimeters. Once assembled, there was no turning back. This machine was not temporary, it was not flexible, it was a permanent decision. When the engine started for the first time, the ground responded differently. Not dramatically, not violently, but noticeably. At this scale, weight is no longer just weight. It becomes pressure. It becomes influential. The blade didn't cut into the soil, it convinced it to move. On paper, the numbers were staggering. The volume of material moved in a single pass exceeded what some entire operations could manage in an hour. But those numbers hide the truth, because power was never the real challenge. Control was. The larger a machine becomes, the slower the world reacts to it. Hydraulics take longer to respond. Momentum becomes unforgiving. Mistakes no longer announce themselves immediately. By the time a problem becomes visible, it has already grown. Operators learned this quickly. Inside the cab, everything felt calm, almost too calm. No sudden jolts, no aggressive feedback, just steady movement and constant pressure. But that calmness was deceptive. Every decision had to be made early. Every movement is planned well in advance. Because once the machine committed to a direction, it could not simply change its mind. This bulldozer didn't reward instinct, it rewarded foresight. Operators described the work not as physically exhausting, but mentally draining. You were not reacting to the ground. You were predicting it. You weren't driving a machine. You were guiding a process that could not be rushed or interrupted. One small misjudgment could alter a slope. A slope could affect drainage. Drainage could shut down an entire section of a mine. At this size, consequences did not stay local. Mining companies began to understand the cost of scale. Yes, the D575A could replace multiple smaller machines, but it could not replace flexibility. If one small bulldozer failed, another could take its place. If a single giant failed, everything stopped. Maintenance became an event. Repairs became projects. Downtime became catastrophic. And then there was the question no one liked to ask. What happens if this machine is no longer needed? You could not simply sell it. You could not move it easily. You could not repurpose it. The D575A did not adapt to mines. Mines adapted to it. As mining philosophy evolved, priorities shifted. Efficiency became more valuable than spectacle. Data became more powerful than raw force. Multiple coordinated machines became safer than one colossal risk. The industry began to move away from singular giants and toward intelligent systems. Komatsu never publicly labeled the D575A a failure, because it wasn't. It did exactly what it was designed to do, but it also revealed something uncomfortable. There is a point where increasing size no longer increases progress. Beyond that point, power becomes fragile. No true successor was ever built. No second generation followed. Not because it couldn't be improved, but because the world no longer needed it. Today, when we watch this machine work, we are not watching efficiency. We are watching a question being answered. How big is too big? And the answer is not found in numbers or specifications or production figures. It is found in silence, in the way the machine moves without urgency, in the way the ground yields without resistance, in the knowledge that this level of force requires restraint, not aggression. The Komatsu D575A did not lose relevance. It completed its purpose. It showed engineers where the boundary lies between ambition and excess. And once that boundary was found, there was no reason to cross it again. The machine did not fail. It finished the conversation.